Okay, got that. And the last day of our project is actually this coming Sunday, so the 31st of October. So we've been working now for 2 years. It's been a very busy time, very busy project. Our project was assisted because we originally started some of the technical developments for a similar project in Mongolia in 2018. So in a sense, we kind of copied and pasted some of the technical solutions from Mongolia to Sibelius. And it's also worth mentioning that for the majority of our project this last 2 years, obviously we've been working during the COVID pandemic, which has meant that lots of the plans that we had to come to Kyrgyzstan weren't possible. At the beginning of the project, we had a number of meetings. You can see some pictures there. But then since then, we've got used to working virtually, which has been a different experience, but we found it's often actually worked quite well. So it's been quite an interesting learning experience that we can do lots of work in terms of things like training and that kind of thing using platforms like Zoom. So there's some logos from our project team. And you'll note that the UK Space Agency have a logo there, and the UK Space Agency are the sponsors of our project. So they've supported the work that we've been doing. And the Sibelius project is a part of a larger program, which is called the International Partnership Program, or IPP for short. And you can see on the map there that the IPP program has supported projects in 47 countries across the world. So it's been quite a big project. It's but unfortunately it's coming to an end currently. So the UK government has different priorities, so that funding is coming to an end, which is why our project's kind of coming to an end. But I think the general sort of feeling is the International Partnership Program has been very successful, and a lot of the projects. You know that the UK has the presidency of the COP26, which is happening in Glasgow in the coming weeks, and a lot of the projects from the IPP program are presenting work in workshops and things surrounding the COP26, including our work in Kyrgyzstan. So the main focus for our project has been on trying to help the herding community, and the rationale for this is the large percentage of the population is dependent on livestock herding, and herders are facing a number of challenges. Deteriorating pasture conditions is something which is frequently cited, and a lack of basic information about pasture, especially in the mountain regions which are used for the summer pastures. And many of the problems that are being faced are being exacerbated by climate change, including the things like the fact that snow is becoming less predictable, which is making it more difficult to rely on melting snow water for irrigation in the villages. So our overall sort of thesis, if you like, is that satellite Earth observation can help with these problems. So satellites can monitor environmental conditions efficiently, regularly, consistently, helping to allow better informed decisions to be made by various stakeholders. When I talk about environmental conditions, the main things we've been looking at, you can see from the icons there, are things like pasture, information, snow, and drought. So the main satellites we've been making use of, I've shown here. So on the left, you've got two satellites, Landsat 8 and Sentinel-2, which are what we refer to as higher resolution. There are different definitions of what high resolution might mean, but they're kind of typically 10, 15, 20 meter resolution. So you can see in individual fields, that kind of thing quite adequately. And on the right, we've got MODIS and VIIRS, which are considerably lower resolution, but the advantage they have is they see they look at the Earth much more frequently, so you've got a better chance of seeing through the clouds. Kyrgyzstan is, I'd call a moderately cloudy country, a little bit like the UK. So you need to have a few looks in order to guarantee that you've got a clear sky to see through with these visible channels. So the heart of the technical solution for the Symbiosis project in both Mongolia and Kyrgyzstan are open data cubes. So in Kyrgyzstan, we've called this the Kyrgyz data cube. And basically a data cube, an open data cube, is an efficient way for storing and accessing large volumes of satellite data and derived products. And by derived products, as I sort of mentioned before, this is typically information about pasture or snow or drought, etc. So you can see there, I've just highlighted the volume of data. So lots of data and kind of growing continually. And you can see there from the numbers, the data goes back a number of decades. So the data is stored in the data cube, and the idea is that it's an efficient way for accessing the data. Something else which is important for us is that the design framework for the data cube is based on the open data cube philosophy, which is originally pioneered by Digital Earth Australia. So a key point here is that it's designed to foster a community, develop and grow applications. So this and a key thing is it will always be 100% open source and free to use. And there is a kind of community which is important for the sustainability of our project, because it means that the data cube, people who are interested in the data cube can sort of tap into this community and ask questions without having to pay money. So the data cube is actually a physical thing. It's some open data cubes are hosted in the cloud kind of facilities, but we've hosted ours on physical servers, and in April 2021 we shipped that to Kyrgyzstan, and that's now installed at the Central Asian Institute for Applied Geosciences, which is also known as SIAG or KAYAG. So they have a presence in Kyrgyzstan, and they have done for a number of years, and they're a well supported group. So since that time, since April, we've been working collaboratively, the UK team and SIAG team. And before we made our choice of where to site the data cube, we hired an independent consultant who did a survey of quite a large number of institutions in Kyrgyzstan, looking at things like the facilities and the level of education of the staff. And on all these measures, the SIAG came out very well. And in particular, one of the main things was SIAG has a commitment to openness. They're sort of not allowed by their sort of constitution forbids them to sell information. So they already have a number of services that they provide for other Kyrgyz institutions. So they do that on a free and open basis. So you can see a photograph there of, I mean, we weren't able physically from the UK to go there in April, but our colleagues from Mersico went over there. So there are a number of different ways to access the data cube. Perhaps I'll start with this slide actually first. So this slide indicates different ways of accessing the data cube. So the top one, the Sibelius visualization website, is the easiest method. And the other ones below are more for the specialist users who actually want access to the data who want to see what the pixel values are, who want to compare one year's data with another year, that sort of thing, and people who want to use Python programming to analyze the data. However, the Sibelius visualization website, which I've shown a picture of there, is kind of by far the easiest way to access the data. And if we've got time later, I'll sort of show this kind of live, if you like. But you could see you've got different languages here. So I mean, I normally sort of open it on the English, but you can switch to the Kyrgyz or Russian languages. And you've got a date selector here. So what you can see here is an RGB image or a visual image. So it's showing Kyrgyzstan as it looked at the beginning of October. So you can see an increasing amount of snow is occurring across the land. You've got a date selector, so you can choose. So you can go back in time and look at different years, or look at how the conditions were in the summer. And then here we've got, if you click on this one, you've got pasture, snow, drought, temperature, other layers, that sort of thing. So this is the easiest thing. One of the things we found actually is we designed this website to be deliberately very simple. It's not a geographical information system. It's not a GIS system. So yeah, people sometimes ask us, why can't it do this and why can't it do that? We've designed it to be relatively simple. If you want access to the data and you want to do more sort of analysis, then you need to access the data through these other methods, which is not that difficult to do. So I thought I'd say a little bit more about, that our project has not just been a technical solution. We've done a lot of work working with people in Kyrgyzstan. So one of the first things that we did was went out talking to people in the countryside. So we have two main sort of test sites where we've been working, one in the north and one in the further south in the country. So these are the actual names of the towns where we've been working. So in our first set of interviews with people, we spoke to 203 households to try and understand people's requirements and their priorities, what kind of information they're currently using to do their agricultural and herding work, and where there are gaps in that information, and also for us to understand the sort of technical infrastructure in the country, the extent to which people have either laptops or mobile phones or Wi-Fi and that sort of thing. And one of the other things that we were doing was defining a resilience metric. So that's something our colleagues from the University of Leicester were working on. You can see here a number of graphs, which I've just sort of put there just to show you that we were gathering information and analysing it. So the Sibelius resilience metric was something which we developed to try and understand people's perceptions of their own resilience, and how they coped with kind of shocks and changes to their livelihoods. So we've just actually been out doing some further surveys with the same, as far as possible, the same groups of people. So we interviewed these people almost 2 years ago, and then we've kind of just gone back to re-interview them. We haven't had a chance to analyze that data yet, but we're sort of in the process of doing that. But of course, the big thing which has happened between the two dates, between the sort of baseline estimation and the final end line survey, is the pandemic, which was obviously going to dominate their lives over this period. So we're not quite sure how that's going to affect our results, but it'll be interesting to see. So in addition to the work with people in the countryside trying to understand their requirements, we've done a very extensive programs of training. So I've sort of slightly separated the training in terms of people in the city, which is mainly in Bishkek, and then people in the countryside. So I've listed a number of institutions where we've provided training. So a lot of this is sort of about how to access information from the data cube, and things like Python training and Jupyter notebooks. So we've estimated we've spent about my colleagues, in particular Filippo, who's here, and my colleague Jack, who's also on this on the call today. They've provided about 47 hours of training and generated lots of training materials and videos which people can have access to if they wish. And then, as I mentioned, this is all, in fact, all of the training in Kyrgyzstan we've done has been done virtually. So typically over platforms like Zoom or Skype. And then, in addition to the countryside, in addition to the training with institutions in Bishkek, we've also done a lot of training in the countryside. So this has mostly been done by our partners from Mersico, so in particular Nagima. So if we've got time at the end, perhaps you could say a little bit more about this. So we did a series of training sessions with the pasture committees. We realized quite early on that pasture committees in Kyrgyzstan are a very important and trusted form of information and a way of organizing how herding is done in the country. So we've worked quite extensively with them throughout the project. So our first sets of training were a little bit of a hybrid of in-person and virtual training. So there's a picture there of me. Well, you can see my picture on the left there. But Nagima was in the room, sort of following up with follow-up training. And then later, just in September, we did some more training with the pasture committee people in the countryside, but this time with some agronomists and agricultural specialists to help try and explain better how they can make use of the satellite Earth observation data and the information from it in their sort of working lives. You know, how to make better informed decisions. So there's quite, again, so this was like 54 people took part in the trainings in these from the pasture committee. So we've reached quite a lot of people. So I suppose our sort of general message that we'd like to communicate really to people is, you know, this project now is coming to an end, but the project has kind of provided a system and capacity for people to use in Kyrgyzstan. So the Kyrgyz Data Cube is an asset now for Kyrgyzstan. We would like to encourage people to use it as much as possible. I mean, we've kind of focused in our project mostly on issues to do with pasture, but we believe there are lots of other applications that people might want to look at with the Data Cube, and we would encourage people to try and think of ways to use it. I kind of feel in a way there's almost like 1,000 PhDs waiting to be written. You just need to use your imagination to think of ways in which you can use the data. So I'll just go through a few of these ideas. So this is kind of not a new idea. So we, as mentioned, our main focus was on pasture. And this is one of the examples on the right of something which we were distributing. So this is a kind of pasture summary sheet for a particular point during the year, which we distributed quite widely. So we distributed, Nagima distributed this through various channels in Bishkek, and we also put it on our Facebook page, which reached quite a wide audience. And then this is the visualization website, just showing it can be used by anybody. And this is just a little example of a project that we did in not this summer, but the previous summer with a student. So we had a student called Megan who's a physics student, but she's never had any previous experience with working with satellite data or geographical information systems. But she did quite an important bit of work for us, which was to use the satellite data to look for the Karagana bushes in the Susama Valley. So Karagana is an inedible bush which is not edible by livestock. So you can see in this picture down the bottom, it has kind of yellow flowers in the summer. So Megan was able to update a previous map, which was created in 2014. So you can see the map on the top of the picture there. So part of the reason for just mentioning this really is the fact that it really is quite easy to use the data to do applications which are quite useful. And as I say, Megan wasn't an expert in this area. She just sort of did this in a few weeks, really, during the summer. So agriculture is another area where we're aware there's lots of opportunities for making use of satellite data. I mean, it's not something we've really focused on in this project, but the data is all there. And if we sort of go through different dates in the year, you can see that the change in fields. So I'm just going to do that. So with satellite data, you're able to see how the crops are developing through the year, looking at whether there's enough rainfall, whether it's necessary to irrigate if you have that as an option. And increasingly commonly, people are using satellite data to predict crop yields, which is not the simplest thing to do, but you can obtain a lot of information about how well crops are developing in general. So, and the satellite data that we have in the data cube is, as you can see here, you can see the individual fields quite clearly, and you can zoom in quite a lot further. So then one of the other areas which we'd also like to emphasize is climate change. The charts on the right here are from a World Bank report, which is a little bit old now, 2010, but the point it's trying to make is that Kyrgyzstan is very sensitive to climate change, mainly because of its topography. It's a very mountainous country. But it's also one of the least, currently, or in 2010 at least, it was not terribly well adapted to climate change. So it's kind of on the wrong end of both of these graphs. So we believe that, satellite Earth observation is one way to help understanding better what's going on in the country. There are many projects in Kyrgyzstan which are focused on climate change, which aren't making use of satellite Earth observation. And when we understand more about those projects, we often think it would be so much. There are lots of ways in which it would be easier to do their work if they did make use of satellite data. And in particular, one of the things that's which you can do, which is very useful for using satellite Earth observation, is monitoring the impact of projects. So whether you're looking at projects which are to do with forestry or pasture or other things, you can make use of satellite Earth observation to observe, to monitor your impact. So you can look at the data before you made your impact, during your interventions, and then afterwards, and you can try and understand, did that intervention actually help? If there was a reforesting initiative, did the trees actually grow? Was it successful? So it's a good way to try and provide quantitative measures for understanding the success of projects. So that's something which we hope will be increasingly used. Something else which we're very well aware of, or become increasingly aware of, is carbon sequestration in rangelands. I think a lot of people are aware of the fact that trees soak up carbon dioxide. But grasslands and rangelands and the soil underneath are also capable of doing this. And our attention was caught by the fact that Microsoft recently paid $500,000 to carbon credits to an Australian cattle rancher, because the cattle rancher was able to show that he had increased the carbon sequestration in the land that he works on. And the evidence that he was able to provide was provided by satellite data, or satellite data in conjunction with some measurements on the ground. So this we sort of feel this is almost an area which we think could be, there could be potential in Kyrgyzstan as well. Basically, livestock grazing helps to stimulate plant growth and helps to increase the carbon capture in the ground. So snow and hydrology is another area which we understand is very important. So when we were out talking to people in the countryside, one of the things that they reported, quite a lot of people reported, was that there are lower levels of snow some years, which are leading to water shortages, and they need the water in the villages to irrigate their crops, and also the fodder crops, which provide the food for the livestock during the winter. So satellite data can tell us about snow coverage. It's not very good at measuring snow depth at a relatively good high resolution, but the image on the bottom right shows you something which we had another student this summer, Nagima, who spent a little bit of time looking at the data in the wintertime in Kyrgyzstan at the snow. So things like snow anomaly graphs. So the bottom right one is showing you how the snow conditions were different in this particular period. So this was from February 2021, and it's showing you there was less snow in February 2021 compared to what there is normally for February in Kyrgyzstan. And the graph on the right is, on the left, is showing effectively the snow line where the snow doesn't melt. So the tops of the mountains where the snow never melts. It's showing you that it's kind of it's decreased a little bit over the last, since 2003. But also you can see it's quite a bumpy graph, kind of changing. So that's basically just to show you, again, Nagima was a student without any previous experience of working with satellite data, but she was able to quite quickly start doing analysis on the data. And so this is something that we've just started to talk to the team at SIAG about. So monitoring glacial lakes. So there's a large number of glacial lakes in Kyrgyzstan, and quite a lot of them are often at danger of bursting out, which can cause floods lower down. And so I've sort of included a line there. Since 1952, there have been 70 really quite serious outbursts in Kyrgyzstan. And these lakes, obviously, they're glacial. They're high up in the mountains, and they're very difficult to get to. But with satellite data, you can see them relatively easily, just on your laptop in your office. So you can sort of keep an eye on what's going on without needing to actually go up there. So we've been talking to the team at SIAG, and they've got a number of people who are interested in snow and hydrology and glaciers. So they're starting to look at this now. Okay, so this is I think it's more or less my final slide. So yeah, to all the people in Kyrgyzstan we've worked with over the last 2 years, we'd like to thank them for their hospitality and support. And it's been a real pleasure for me and for the UK team to get to know Kyrgyzstan. It's not a country most people in the UK are that familiar with, I think. It's probably fair to say, but we've suddenly learned a lot about the country in this time, and it's been a real pleasure. And again, we'd like to encourage people to think about how satellite data could help you in your work or your research. And as I mentioned before, the Kyrgyz Data Cube is a resource for the Kyrgyz people. So yeah, please use it. And that's my final slide. Thank you very much.
Thank you very much, Nick, for this nice presentation. And I would like to talk to the audience. If anyone has any questions, please raise your hand. So yeah, Erkin Isaev was no, he lowered his hand. So Tilman Brook, please, you have a question, please go ahead and ask.
Technical problems with the unmute button. Okay, thank you for a wonderful presentation, Nick. I really enjoyed that. You may have been at the opening. I'm the principal investigator of the Life in Kyrgyzstan study, where we have panel data from over 3,000 households over 10 years from across the country, nationally and regionally representative. And we've been thinking of using remote sensing for a while to try to understand what is happening without always knocking on doors and having to bother people and saying, how's your field and so on. Yeah. One of the challenges for us is that, in a sense, we would like to link each individual's land to what is happening. So if we could, look from above what this farmer's or household's land is happening in terms of, what crop are they growing, for example. Yeah, that would be fantastic. There were two challenges to that. One was resolution, simply knowing in enough detail, because the plots are not necessarily huge. Yeah. So, and if we don't talk about grazing, higher up, but actual fields, then it gets a bit more difficult. The other one was farmers weren't very happy to tell us exactly where their land is, because they said if you then look at the data and have the land identifiers, then you basically de-anonymize the household that's behind that, because everybody locally knows that the plot behind the tree, is owned by this household as opposed to that household. But I wondered, do you see any other opportunities for linking?
Что касается других возможностей, как связать
with individual households, is that a way forward, or would it basically boil down to this community, had a lot of snow, or this community has a lot of ground cover of X, or this community, which would reduce, how can I say, the statistical power of our data, right? If we only had it at the community level. So this community versus individual, that's what I'm sort of struggling with as somebody who's usually using household survey data. Thank you.
Yeah, I suppose, I mean, one of the things we found out during the initial surveys we were doing is that most individual households don't have really the access to, well, it's a little bit mixed in terms of internet connections, that kind of thing. Most people have mobile phones, but very few people, but mobile phones are not ideal really for looking at this kind of satellite data. So we kind of felt probably the best way to reach people was through, well, things like the pasture committees, which is why we kind of spent quite a bit of time focusing on that. I don't know if Nagima would like to say a little bit more about that, but also another area which we started to explore, which we probably didn't get quite as far with as we would have hoped, is Mersico were instrumental in setting up a bank in Kyrgyzstan called the Companion Bank, and the Companion Bank have quite a lot of people who work as agronomists and livestock specialists who work actually in the countryside. So we kind of felt that probably the best way to kind of make an impact on a kind of ground level in villages, remote villages, were through these kind of people and stakeholders who do have access to a bit more technology, and they have a bit more experience of providing advice to people. So we were trying to work with the Companion Bank and, as I say, the pasture committees and the and also other officials in the villages. I don't know, Nagima, would you like to sort of expand a little bit on that? I don't know if Nagima. Maybe she's not getting the translation. I don't know whether that more or less answers your question.
Okay, thank you very much for the question, for the answer. The next question, Mr. Muratbek Aljibayev, please go ahead.
Good afternoon, and thanks for the presentation. My question is about the data. Well, pardon my ignorance, because I'm not a GIS scientist or anything close to this, but I have colleagues who also wonder about the resolution of the data. And as someone who's interested in natural resource management, the scale really matters a lot. And so the closer we get, or the higher resolution rather we get, is the best. So as you were talking, I was surfing through the website, and most I see is, well, again, it seems like quite broad scale. So if I just look, for example, at the Pasture trend, it has scale of -50 to +50. And then the others ones are even more, 1,000 kgs per hectare and so on and so forth. And I'm just wondering if, if I'm in the Pasture Union Committee or whatever the unit is, and I want to see what's happening in my pastures, and I don't really have the equipment to go up and observe, what's going on up there. How much does this data allow me to do that, to be able to basically monitor the state of the pasture in terms of biomass or whatever in my locality? And then follow up to that, if that kind of resolution is available, then where is it in the website? I'm struggling to see where to get that, especially for someone who is not an expert in GIS and you cannot deal with these things. Thanks.
Okay, perhaps it might be easiest if I just share my screen. I don't know if that's, hopefully you can see that again. So this is the visualization website. So one of the key things which I said before is this is not a GIS tool. So there's lots of things you can't do here, but we provided it as the simplest possible way to sort of get information about the what's going on. So when you sort of open this up initially, what you'll see here is the lower resolution data. So the resolution of the data here is a few hundred meters sort of pixel sizes. But the way we've designed it is so that if you zoom in, there's a point at which it switches to the higher resolution data. So the best way to sort of show the general resolution of the data is to show fields. So you can see you've got quite a lot of pixels for each field. So that, there's a reasonable amount of, so this is actually 10 meter pixels. And so you can see roads and buildings and things. And if I sort of, as I mentioned before, you could sort of go back in time and look at different dates. And so this is the RGB. So this is a red, green, blue. So this is just like the visible channel. So this is almost like a kind of photograph from the satellite. But then if you were to go to the pasture, well, the vegetation index kind of tells you how much kind of green vegetation there is on the ground. So that's something which is very familiar to lots of people working even in agriculture. We have also converted that to a pasture biomass. So if I add the legend here, you can sort of see this is pasture biomass in kilograms per hectare. So obviously this is a kind of color scale. If you actually wanted to see what the pixel values were in the individual pixel values, that's kind of the point where this tool, this visualization website is no longer going to be useful for you. You need to use one of the other routes to access the data, which we We've provided a lot of training for how to do that. And there are a lot of people now in Kyrgyzstan who do understand how they can do that, but you can't really do it. We can't click on here to see the actual numbers. But as I say, you've got a sliding scale here. Actually, yeah, we always feel that pasture anomaly is quite a useful metric. So this is telling you how the conditions right now compare to the historical average for the same time of year. So obviously when you're in the fields, because they're different, because they rotate the crops, there are different fields, different crops grown each year. It's very, very sort of bumpy. So red, if I turn on the legend, it tells you whether the biomass is above or below what it normally is. So red means less biomass than normal, green means more than normal. But if I zoom out, it should hopefully switch to the lower resolution. And I mean, one thing which we noticed earlier in the summer was that it was quite a lot. It was kind of reddy in color, and we were told that there was generally there wasn't quite as much rain in the early part of the year. It looks a bit strange. If I turn the lake layer on it, oh, it's not turned on. Okay, normally it covers the lakes. So I suppose in answer to your question, the pixel size is of the order of 10 meters if you zoom in. So so this is zooming into a sort of pasture region, and this is again, it's in July, so sort of peak time, much less back in May. So you can see how things develop over the year. I don't know if that's helpful.
Yeah, thank you very much, Nick, for such a detailed answer. And I think we have some time left for the last question. So, Erkin, please go ahead.
So, good afternoon, colleagues. Thank you very much, Nick Walker, for your presentation. I have two questions. First question, as I see in your visualization website, open data website, the frequency of data, for example, for Sentinel and for other data, has increased. When first visualization website was created and testing, there was my comment to the Filippo of Contenta to increase the frequency, and in the first stage they're using third level data, remote sensing data, but right now I think it's the second level data. Am I right? Because the frequency increases of updating this information in your visualization website.
I'm not completely sure I understood all the question actually, but I'll try and I think if one of the questions was
now we are using second level data or third level data, remote sensing data.
Well, one thing which is useful to sort of point out is it is possible to export data here. So if I log in here, okay, so I'm already logged in, I think. If I wanted to save the data, well, perhaps that's not the most interesting image, you know, but if I wanted to save this as a PDF or a GeoTIFF, we have this facility to do that. So GeoTIFF, if I download something as a GeoTIFF, then I can read it into a GIS package, for example. But if I wanted to write a report, that kind of thing, I would be able to do that So there's this thing here, print. So I can print it, or I can save to a PDF or whatever. So that's one. I think you were asking about about that, but I'm not. But I didn't quite catch the other part of your question, Erkin. Sorry.
Okay, I will ask to Filippo. It's more technical question.
Yeah, I think. Can you hear me?
Yeah.
Yeah, I think that what Erkin is asking is whether we. So at the beginning, we were using level 3 data, while now, as he requested, we are using the level 2 data. So it's the delay to get the new data is much shorter. So that's the case, essentially. So you just have to wait for a few days for the new data now.
Yeah. So we are. Yeah. Well, one of the things that we're doing for the products is we're creating a kind of best product over a time window. So the satellite looks at the Earth a number of times during, for example, a 10-day period, and we take the best images from that 10-day period to create the products. So that's so we've always got this kind of rolling window, and the reason we do that is because, as I've mentioned before, and as you probably know, Kyrgyzstan is quite a cloudy country. But yeah, we're trying to use the most up-to-date data possible.
Yeah, thank you very much, Nick, for the presentation, for answering the questions. And let's move to the next presentation by Erkin. The title of the presentation is Drought Detection and Modeling in Kyrgyzstan. So please, Erkin, go ahead. The floor is yours.
So now I'm starting to share my screen. Can you see?
Yes, we can see your screen.
Yes, I want to talk about drought monitoring and early warning system in Kyrgyzstan, which it started to creating from 2019, and up to now, due to the COVID situation, it's now in the pilot stage. And I will tell about verification of the moon sensing and meteorological drought indexes in Kyrgyzstan and how we are now doing this kind of monitoring and prediction of drought. So this was done with supporting of UNSK project. The funding was from Russia, and they were collaborated with Kyrgyz Hydromet, University of Central Asia, and Chinese Academy of Science. So a little bit information about climate, which Nick is showed. You can see the annual anomaly for Kyrgyzstan is increasing. The positive anomaly is increasing, and temperature is increasing for all seasons: winter, spring, autumn, and summer. But there is no significant trend for precipitation. But if you will see the monthly distribution of the precipitation, you can see significant part where the vegetation period, especially for summer, the negative anomalies for precipitation for some stations. So if you know that climate is changing, and global circulation of atmosphere is also changing. Where the global atmosphere is changing, over such a territory as Kyrgyzstan, mountain territory, the adaptation of atmospheric process also becoming, and the frequency of natural disasters is increasing. Here you can see most recent disasters, and all 70% of disasters are related to hydrometeorological disasters. But the last 10 years, this kind of disaster slowness, like drought, was become more frequently, and up to 2019, there was no methodology in Kyrgyzstan, especially in Kyrgyz Hydromet was mandatory to the monitoring of drought and focus of drought. There is no methodology, there is no anything, and that's why in 2019, we started with recommendation of World Meteorological Organization. We verified that the index we can use, and we start to use it in operational practice in Kyrgyzstan, calculating this standard precipitation index to drought detection. And then we prepared project proposal for UNSK, and they are supported. And this kind of project was started development of decision-making tools for geo-drought monitoring and early warning in Central Asia. The pilot region was chosen Kyrgyzstan, and this was the map of our system. First of all, we need this kind of seasonal forecast for prepare forecast. And we have a two stage. First of all, we illustrate good monitoring system by using remote sensing, ground observation, and other things. So, in this work, what we did, we verified 6 remote sensing indexes and 3 meteorological indexes. This kind of data we use in our work, in our research. For example, more than 90 years ground measurement of the all meteorological parameters and statistical data about yield productivity for each oblast and for each crop type, and also this kind of remote sensing data. So here we calculated meteorological index, standard precipitation index, standard precipitation evaporation index, and PED. We here the 3 month indexes, which by recommendation World Meteorological Organization, the meteorological indexes, for example, from 1 to 3, 1 month index, it shows the meteorological drought. From 3 months to 6 months, it shows agricultural drought, or you can say soil drought. From 10 to 12, it shows a hydrological drought. So for the soil drought, you can see here, and we know that from our statistic data, the 2040 was very dry year, and the all 3 types of drought was, and Kyrgyzstan was under the all 3 types of drought. And 2060 was very wet year. There is no drought. There was no drought in the Kyrgyzstan. By calculating the index, you can see APIU show APIU 3 for most responsible for soil drought, shows that all Kyrgyzstan is under drought, and when the wet year, we can see that all of them are wet and moderate. So APIU shows some part is drought, but some part is wet, moderate, and mildly wet. But PED shows everywhere wet. But PED now in Mongolia and in Russia was the best meteorological index, but in our territory it doesn't work. So here for APIU 5, the same you can see. And to verify the soil drought, agriculture drought, we use ground measurement from Kyrgyzstan from 31 meteorological stations, and there was 1, 2, 3, 4 soil. There was data about soil measurement for depth 10 centimeters, 10 centimeters, 50 centimeters, and 100 centimeters. So we know that 2040 was very dry year, and 2060 was very wet year. So you can see here, the index shows that in Mersico station we have drought, extreme drought, and by the soil moisture we can verify yes, it was very hot. 2060 there was very wet year. The all data was correlated by this, but for the pay index here in the south region it works, but for the Arbashi and for the Stott region it doesn't work, because it shows that here was some mild wet, but we know that mild wet, but we know from the ground measurement 2040 was under drought. As you see here the soil moisture. So we cannot use this pay index for this region. And why only for SPE shows this kind of result for 2040 and 2060? Let's talk more detailed about this case. Here I thought about average mountain temperature in Alimbekova in Tokmak station. You can see that if when we are calculating stay index, we have also taken into account temperature, but SPI we are calculating by using only precipitation data. That's why, for example, 2040, you know that here was drought, but stay shows it's normal. There is no drought, and wet, mild wet. But let's see the temperature. The temperature, average temperature was the same as in 2040, and that's why this index when I'm calculating, it shows that if we have precipitation and less temperature, it shows no drought. But in the practice, we have drought. That's why we cannot use this for all regions. PED index we cannot use because both dry year, wet year, it shows wet. So for hydrological drought, we also calculate it for 11 month indexes, for under precipitation index, for stay and set. So let's verify these indexes by using average discharge from hydrological post for this period. As you can see here, SPI shows that in the region of Sikul, in the region of Talas, we have some hydrological drought, but here we have in Bishkek, in Chayek, and in Uzgen region, we have some mild wet. There is no drought, there is mild wet region in hydrological aspect. And they also show this kind of map, but PED shows all of their wet. So let's verify. So this year we know that there was a hydrological drought in the Mersico region, in Talas, and the others. And we have very wet year. So we can see here in Uzgen region, station hydroport number 5, it shows there is nothing changed. And also in SPI index and SPI index is nothing, but here is the change. There is also mild wet and mild wet. So we can use this SPI index for hydrological drought detection. But SPI index shows here mild wet, but in this region shows mild drought. So also we cannot use this SPI 11 index for hydrological drought detection in this region. PED we cannot use because it's not involved. All of them are flat. So if you calculate the NDVI and average NDVI for all countries, we can see here the wet year, the drought, also here was the drought, but here's a little bit normal. But only one region, Batbuyan region, South region of Kyrgyzstan was under the drought, but all of the region was under the normal and in the 2018. So but we need more detail for region district level because of use remote data. For example, for 2040 years, that all Kyrgyzstan was under the drought, this vegetation period, the vegetation remote sensing indexes here. As you can see, the VSWI show there is no drought. But we know that this year and this month there was drought. We Kyrgyzstan all three types of drought. So vegetation health index, vegetation condition index, and temperature condition index, NDWI show the drought. And we know that 2060 was very wet year, and all indexes show, except NDWI, there is a drought. So in both for drought detection and for wet year detection, vegetation health index and vegetation condition index and temperature condition index is the best for drought and wet year detection. So vegetation health index is calculated by using two indexes to giving some weight on them. So and also we calculated some correlation coefficients and correlation analysis between yield productivity and this kind of meteorological index. So we can see more correlated and indexes are here for the Issyk Batbuyan region are mostly dry, wheat and barley. Because of wheat and barley are mostly wet croplands and not irrigated croplands and drought most affected. But other crop types are mostly used croplands, irrigated croplands. That's why there are very less correlations. So we did this kind of correlation analysis for all regions, for all crop types, and used this indexes, correlated indexes, when we are creating some common drought indexes by using all meteorological indexes and remote sensing indexes. We create some common drought indexes by giving some weight for each indexes. So here is some correlation about remote sensing indexes and yield productivity, and you can see vegetation condition index, nutrition condition index, and vegetation health index more correlated with crop data. So we did for all regions the same, and by using this information to create a common index. And also here we create some information about the soil measure and remote sensing indexes of the soil measure from remote. You can see that here the mountain stations, the oil stations, here the formatted data we create for sentinel data. So it's not so long for it, it's not so difficult. It starts from 2050, 2060. So you can see all the stations were correlated from the surface layer, but here is no correlation, no significant correlation due to the amount of station. Because one pixel, for example, model data or the other data is 250 meters. One pixel is very high resolution. But for the weather station, the homogeneous space, more homogeneous than mountain, that's why more correlation. And we did also the kind of indexes also. Also, you can see vegetation condition, the vegetation health index more correlated with the remote sensing index. And then we did this kind of thing for all regions and choosing common index and giving weight for common index for each region and for each district. And also we create, for example, +1 now, a correlation between the meteorological index and remote sensing index, but adding the +1 now, because you know that we have some inertia between meteorological drought and, for example, agricultural drought, some inertia must be there. So by adding some 1 month, we are increasing the correlation. So in conclusion, what we did, meteorological index for drought estimation, this kind of 3 indexes were estimated. Special consistent meteorological index PCI is better than others for Kyrgyzstan. But secondly, more meteorological indexes should be involved for analysis, such as PDCI, QDCI, and others. There are a lot of indexes, and also we need to estimate the indexes and verify which one is the better for Kyrgyzstan. And by drawing out meteorological indexes, that was made by interpretation of IDV methods, but we need also conduct some research about choosing the best interpolation methods. Remote indexes, these 6 remote indexes were estimated, and vegetation health index, radiation condition, temperature condition index shows the best results for Kyrgyzstan. And so correlation between soil measure and population drought index is different for mountain and valley region, so we need to use more high resolution data, for example, spectral data. And after discussion with radicalists, we came up to one opinion that we need some field campaign to collect data to improve and collaborate drought monitoring indexes. Here are the future plans, what we are planning, what Kyrgyzstan is planning. Purchase some server and to conduct some field campaign, field work to collect ground measurement data about soil moisture, temperature, biomass, by GPS coordinates, and doing some nesting and calibrate. For example, we don't know the sentinel for Modis data for NDI, how they current some of the data, and add some bias correction when you do drought monitoring by using remote sensing, and also carry out the field campaign by using NDI measurement with a multispectral glass with higher resolution, which the resolution is right now 2 centimeters. Maksim will correct me if I'm wrong. So then calibrate the Drought watch Kyrgyzstan by using this data, and then create a mask and verify. And also, this is only for monitoring, Drought monitoring. And to create some forecasting system, we need first the seasonal, sub-seasonal forecast of precipitation temperature. Right now in Kyrgyzstan, there is no seasonal, sub-seasonal forecast. They are preparing on the monthly forecast. The accuracy is too low, less than 60-50%. So that's why we need to improve also this kind of seasonal, sub-seasonal forecast to give some forecast of those. So that's all. Thank you very much.
Yeah, thank you very much, Erkin, for the presentation. And if anyone has any questions, please go ahead, raise your hand. So if there are no questions, then I have a couple of questions. First, did you, Erkin, have a look into correlation, spatial correlation between NDVI and the drought indices? I saw several correlations between the drought indices and yields, but I don't think I have seen the one with NDVI.
So there will be very good correlation if we will. So the vegetation health index, other remote health index is calculated by using NDVI and some temperature indexes.
Yeah, they are directly related, right? So there is no sense in calculating any correlation between them. So, and another question, you have shown some correlations between the drought index and crop yields, and where did you get the data for the crops? How and how they did it? I mean, what form was those data in?
So we have we took this data from Kyrgyzstan and from Static Committee of Kyrgyz Republic about they have yield productivity for each crop type for in region level and in district, but mostly in region level. Long historical data for region level for all crop types. For example, 1 ton per hectare per year.
Okay, thank you very much. And anyone has any questions? So if there are no questions left, then thank you very much for coming to this session. We have seen two very interesting presentations by Nick Walker and Erkin Isaev. Nick presented their web system for indicating, for showing up the satellite images and different remotely sensed indices. I actually had a couple of questions to you, Nick, and but I didn't think if we would have some time, but now I see that we still have some time left, and so I may ask you a couple of questions. So, well, first question: where are the data actually stored? Are they stored locally on the server, or are they accessed directly from the NASA server?
No, they are on the servers are now in SIAC, so they are on physical servers which are in Bishkek in Kyrgyzstan. And I showed a slide which showed what data is there. So going back quite a large number of years, so you've got all the historical data. So that allows you to monitor trends over quite a long period. So if you wanted to look at how snow conditions have changed over the years, you can do that. or if you want to look at pasture conditions, you've got the potential to do that. And one of the products that we have on that visualization website, which we feel is one of the most useful quite often, is pasture anomaly. So that's continually being created, and it's looking at the current pasture conditions and comparing those conditions to the historical conditions for the same time of the year. So you can see whether there's less pasture than normal, more pasture than normal, or whether it's an average year. So that's quite a simple way of just understanding, is this generally speaking a good year for pasture or a bad year for pasture? And of course that tends to be correlated with rainfall or snowfall.
So the server in SAYAG constantly downloads the satellite images from the NASA server and stores it locally, but then it will run out of the storing capacity. So capacity quite quickly. There's a plan for adding up the storage capacity.
I don't know whether one of my colleagues would like to explain how much data storage capacity we've got, but I think we've estimated it's got at least, is it 10? I don't know, Filippo, do you know? Is it like another 10 years worth of storage capacity there? Something like that?
Yeah, I think it was more than 10 years actually. We did an estimation on how much you would, download per year, considering Sentinel-2, Landsat 8, MODIS, VIIRS. And then consider also that there are new satellites being launched for like Landsat 9 and so on. So in case you want to do any updates, it should be more than 10 years. So, and there is, if you, in 10 years time, if you want more space, you can just add a new NAS and then link it to the data cube. It's really no problem.
Yeah, it's also just probably worth emphasizing that we have done a lot of work on, well, particularly Filippo and Jack have done a lot of work on training and trying to sort of build capacity in institutions in Kyrgyzstan. So we've done a lot of work recently with the SAYAG team to ensure they understand how to maintain the data cube into the future and how to sort of get data from it into different applications. And the team at SAYAG are really very well got good backgrounds in IT, and we feel quite confident they understand what they need to do. And as I mentioned also previously, SAYAG as an institution has a kind of commitment to open data in Kyrgyzstan, and they work with lots of other institutions in Kyrgyzstan, like Kyrgyz Hydromets and the pasture departments from the Ministry of Agriculture. So they kind of work in collaboration with other institutions as a part of their national sort of remit. So yeah, they're a good place for the data cube to be.
Thank you very much. And I think we have another question from Erkin. Erkin, please.
Thank you very much. And I have a question for Nick and for Dominic. Can you give Hyderabad is asking about training related to the receiving station and software which installed by your support, if you remember. The antenna and the receiving and software, they asked about training about how to use this software and anything, one day training. For
Dominic and me. I don't know if Dominic,
Dominic.
heard it. I don't know whether you heard it better than I did. You there, Dominic? I can see you.
Well, we'll be in touch actually. We can arrange some training sessions for Kyrgyz Hydro. It's not a problem.
Okay, thank you. I will tell them about this and give your contact.
Yeah.
Yeah, thank you very much, dear colleagues. One last chance to raise a hand and ask a question.